Hey, let's continue our work in Chapter 5 with our exponential and logarithmic functions. And so this section will consider the logarithmic function, and we'll get some details about it, about its graph, how to evaluate a logarithmic function, and then see when we can use those to model and solve real-life problems. So here is where the logarithmic function comes from. All it is the inverse, excuse me, it's the inverse of the exponential function. So remember, when we had an exponential function, it was y equal a to the x. If I were to try and find the inverse of this function, remembering the steps we did, back in I think it was chapter 2, to find an inverse, remember we would swap out the x's and the y's, and then we would try to solve for y. Well, we don't really have a method for solving for y when it's in an exponent position, but let's take a look at the definition of the log. This guy right here, when we swap out x's and y's, is actually the logarithm function. So notice x equal a to the y is the logarithm. But when we're working with functions, we want to have our function in a y equal to format. So we take x equal a to the y and define it as y equal log base a of x. So these two guys are actually a logarithm. One is in the y equal format. One is in the x equal a to the y format. So when you have a logarithm, as with our exponential function, you're going to have a base. So it's defined as log base a of x. So that little a hanging around at the bottom of the logarithm is our base. Keep that in mind because our rules for exponents are going to come into play because we're dealing with a base. So that's where the logarithm comes from. Now let's take a look at some work that we're going to do with it. The first thing we need to be familiar with is the two forms that a logarithm can take. We'll see it in y equal log base a to the x form, and we can also work with it in the x equal a to the y form. So let's practice with those forms by doing some converting. So if I had y equal log base b of x, and I wanted to take him and put him in this format, all I have to do is rearrange those values. And it would be it would be b to the y equal to x. b to the y equal x. So all I'm doing is rearranging these three pieces into these three positions. So if I had the logarithm 2 equal log base 5 of x, I want to rearrange those to be in this format. So it would be 5 squared equal x. 5 squared equal x. All we need to do is recognize the 5 is in the a position, the x is in the x position, and the 2 is in the y position. So I just take these and say x equal a to the y. So x is here, equal to a, which was 5, to the y power, which is 2. We're sort of bringing it full circle. Notice that 5 squared equal to x came from this 5 raised to that power equal to that argument. So if I follow that for this guy, I'll have this base to that power equal to 64. So it would be b to the third equals 64. Doing the same thing here, I've got my base. Whatever the base is on your logarithm, that's going to be your base over here. So it's going to be 3 to the y equal to 7. All we're doing is rearranging those values. Now we'll want to go the other way as well. Suppose I have it in exponent form and I want to put it in log form. Well, 12 is the base here, so 12 is going to be my base over there on my logarithm. The guy that stands alone, the x, is what's inside your logarithm. The exponent right here becomes the number that it's equal to. So let's model that for this one. It's going to be log base what? What's the base over here? It's a b, so it's going to be log base b of what? 8, and that's equal to the exponent of 3. Let's change this one to the log form. So I'll have log base what? Well, 16 is my base. These are all bases. When it has an exponent on it, that's your base. So it'll be log base 16 of what value? The 4 equal to 1/2. So this we want to practice on. Got to be able to convert one form to the other. Okay, so now let's do some evaluations. So let's take a look at this. We've got a function, f of x equal log base 2 of x, and we want to put a 32 in place for x. So basically we want to find f of 32, which would be log base 2 of 32. Now we want to find that value. Depending upon what version of the calculator you're using, a lot of calculators will allow you to just put in the log base 2, the 32, and it'll give you a value. Not sure if mine's going to allow me to do that. I think there's a certain setting you can use. We cannot use this LOG button. He is saved for a certain type of logarithm. But you know what? Email me if you know what that setting is. I know there's a certain setting you can get to where you can actually type in the base and that argument. But since I don't see it on my calculator, here's how I'm going to look at this. Basically, y equal to log base 2 of 32. What if I took this guy and changed him to that exponent form? It would be 2 to the y power equal to 32. Really, all this is asking me is what is the power on 2 that would give me an answer of 32? And if I play around with the powers of 2, we actually find out that 2 to the 5th power is equal to 32. So the answer for log base 2 of 32 is actually 5. All we're trying to do is find the exponent on 2 that gives me a 32. So again, I took it, I rewrote it as 2 to the y equal 32, and I knew I needed to solve for y. Let's try this one. Let's try f of 2 for log base 4 of 2. So that's y equal log base 4 of 2. Let's convert it. 4 to the y equal to 2. And again, I'm trying to find out what is that exponent on y so that when I apply it, I get the value of 2. Well, here comes the knowledge of exponents. Remember, how would I go from a 4 to a 2? Well, if I square rooted a 4, I would get a 2, right? And a square root has an exponential notation. 4 to the 1/2 is actually the square root of 4. Keeping this in mind, 4 to what power would be 2? 4 to the 1/2. 1/2 means square root, and a 4 to the 1/2 power would give me 2. So to answer the question, f of 2 would be 1/2. I know this seems awkward. But if I take it and rewrite it, I'm just trying to find out what is that exponent. Let's try number 3. I need to find f of 1, so it's basically log base 3 of 1. Well, if I write that as y equal log base 3 of 1, and I rearrange this in exponent form, I would have 3 to the y, I would have 3 to the y power equal to 1. So now I need to find out what would that exponent be on the number 3 so the result would be 1. Remember some of those exponent rules we looked at in a previous lab section? Just kind of keeping that in mind. Remember that anything to the 0 power was equal to 1. So 3 to what power equal 1? Well, it has to be 3 to the 0 power equal 1. And remember, our goal is to find out what is that exponent. So f of 1 would be 0. This is going to take some practice, but you'll get there. Let's look at some properties. This may help you. If I have log base a of 1, that will always be equal to 0. Because if I take it and rearrange it, a to the 0 equal 1, anything to the 0 power is equal to 1. So this property right here looks like this in logarithm form. We also know that a to the first power is just equal to a itself. If I took this exponential statement and wrote it as a log, it says log base a of a is equal to 1. Here's another one. If I've got log base a of that same base a raised to the x power, log base a of a to the x is just equal to x. And then finally, the one-to-one property. Log base a of x, or I should say if log base a of x is equal to log base b of y, a of y, notice these two bases are the same. Log base a, x and y. If I have log base a of x equal to log base a of y, then x has to be equal to y. That's our one-to-one property. Remember the one-to-one property we had before for exponents? If I had a to the x equal a to the y, then they just kind of cancel out and I'm just left with x equal y. Well, this is the one-to-one property for logarithms. So what would these properties look like in action? The first one, if I had log base 2 of the number 1, log of 1 is always 0. Log base a of a equal to 1 would look like this. If I had log base 5 of 5, that's going to be equal to 1. So whenever these two bases match, the 5 and the 5, they kind of cancel out, and I'm just left with the exponent. Let's look at this guy. Log base 7 of 7 to the third. Notice those two bases match, so it's kind of like they cancel out and you're just left with the exponent. Or if I had 8 raised to the log base 8 of the number 3. The base is 8, the base is 8, they cancel each other out and we're just left with 3. And then finally, to illustrate the one-to-one property, if I had log base 4 of x equal to log base 4 of 7, the one-to-one property says kind of wipe those out and you just have to work with x equals 7. Let's put some of those properties to work. So we're going to use those properties to evaluate these logarithms here. So when you're working with these guys using the properties, you kind of want to keep in mind, I would like to make my bases match. Because if I can make my bases match, they pretty much just kind of cancel out. Let's take a look at log base 9 of 81. I would like to have this base of 9 also be a base of 9 where that 81 is. So my goal is to try and figure out how can I write that 81 as 9 to a power. We probably already saw it, but 9 to what power is equal to 81? 9 squared. And based on our properties, when that base and that base match up, they cancel, the answer would just be 2. Take a look at this next one. I've got a base of 7, log base 7 of 7. So those two 7s match. What's the exponent on that 7? It's 1. So they match. The answer is 1. Look at this guy. Log base 8 of an 8. Well, those guys are matching. So it's like they cancel out. And in this case, I'm left with 17. So whether it's a log that comes first, or in this case, 3 raised to the power of log base 3, that's all matching. They cancel. I'm left with 5. What about this guy? I've got to do something with that square root so I can have a 6 matching with a 6 to a power. So how can I rewrite that? Well, we saw earlier a square root has an exponential representation of 1/2. So the square root of 6 is equal to 6 to the 1/2. And now that my bases are matching, log base 6 of 6 to a power, the answer is the power. And then finally, log base 6 of the number 1. Remember up here, the log of 1 is always 0, so that answer would be 0. I'll stop this video here and pick up with the next one, or with the next information on the next video.